Welcome in the second video of the design of the bar screen and chamber. In the first video we have designed the bar screen and chamber on the reference of flow velocity through bar and the depth of the channel fixed. Flow velocity through bar was fixed and the depth of channel was also fixed in the first video. Now we design the screen based on the fixed approach channel. In this case the approach channel is fixed or designed, and then we design the bar screen and rack. In the design part, in the step 1 we design the approach channel using the Manning's formula, and in the step 2 we calculate the number of bars and the length of the bar, and in the step 3 we calculate the head loss by the orifice formula and the Christmas formula, and in the step 4 we calculate the head loss in 50% clocked condition. In the step 1 we design the approach channel using the Manning's formula. The equation for the Manning's formula is as shown in the screen. In this example, the depth to width ratio is taken as 2. We consider here the rectangular channel. The slope of the channel is 1 by 500. The peak discharge Q peak is 0.694 meter cube per second, and the Manning's coefficient N for concrete, the Manning's roughness coefficient is 0.012 for concrete. The solution of the Manning's equation is as shown in the screen. The width is calculated as this formula. We can directly calculate the width without using the solver function of the scientific calculator. And by this formula we have calculated the width and the depth of the rectangular channel, which came out to be 0.52 meters. The width, the depth came out to be 1.03 meters. And in the Excel file, the drawing of the channel is automatically generated. The width is 0.52 meters and the depth is 1.03 meter. And in step 2 we calculate the number of bars and the length of bar. We assume the bar size to be 8 millimeter width. We assume the bar clear spacing to be 50 millimeters. The number of bars is now calculated at the total width taken by the spacing plus the total width taken by the bar, and the number of bars came out to be 8.76 numbers, but we round off to greater number, which is n is equals to 9 nos. Now we calculate the actual spacing of the bar. The actual spacing of the bar came out to be 48.47 millimeter. Initially it was 50 millimeter, but we have increased the number of bars, so now the actual spacing is 48.47 millimeters. We also assume the freeboard to be 0.8 meter. In this case it is very high because the velocity in this case is very high, so the clocked height is very high, so we have to increase the freeboard to much higher. In this case it is 0.8 meters. The total depth of the channel will be the initial depth of the channel, which is 1.03 meters plus 0.8 meters, and which will be 1.83 meters. The total length of the bar will be dt by sine theta. The theta is assumed as 85 degree, and the length of one bar came out to be 1.325 meters, and the projected length in plan came out to be L cos theta, which will be 0.343 meters, which will be used in the layout of the bar screen. And in step 3 we calculate the head loss, first by using the Christmas formula. The Christmas formula is shown in the screen. The beta is taken as 2.42, which will be for the rectangular channel. The HB, the velocity head, the approach velocity head is 0.0864 meter, and the angle of inclination will be 75 degree, which is assumed. And by this formula the head loss is calculated to be 0.109 centimeters. Again, by using the orifice formula we calculate the head loss. The velocity, the VAC is the velocity in screen, which is calculated to be 1.733 meters per second, and the VAAPP is the approach velocity, which is calculated as 1.3 meter per second, which is the Q by area of the approach channel. By the orifice formula, the head loss came out to be 9.55 centimeters, and we take the head loss of the greater of the two values, which is 9.55 centimeters. And in step 4, we calculate the head loss by a condition of 50% clogged condition. The approach velocity is 1.30 meter per second, but the velocity in screen is twice the velocity in the clean bar condition, which will be 3.47 meter per second, which is very high. And by using the orifice formula of the head loss, we calculate the head loss to be 75.25 centimeters, which is very high. So we had previously increased the freeboard and kept freeboard at 0.8 meters. This head loss is significantly higher. This is the indicator of screen cleaning time. The screen may also be cleaned by a different percentage of the clogged condition, but we take the clogged condition here as 50%. And in the final, the design summary and the drawing. The drawing is auto-generated in the Excel sheet. The drawing is auto-generated as shown in the screen. The number of bar came out to be 9. The width of the bar is 8 millimeters. The new clear spacing is 48.47 millimeters. The depth of water in clean rack will be 1.032 meters. The approach velocity in the clean rack will be 1.302 meter per second, and the drop which needs to be provided will be 9.55 centimeter, which was in the clean rack condition. Also, the height rise in the 50% clogging condition will be 75.25 centimeters, and the angle of inclination is taken as 75 degree. Up to the freeboard, the depth will be 1.832 meters. Everything is linked and it is auto generated. Also in the design summary, the angle of inclination will be 75 degree. The total width of the screen chamber is 0.52 meters. The width of the flat plate is 8 millimeters. The new clear spacing is 48.47 millimeters. The length of one bar is 1.897 meters. The number of bars is 9 notch. The projected length of bar in plan is 0.491 meter. The vertical drop after bar rack will be 9.55 centimeters, and rack cleaning height level when depth rise will be 75.25 centimeters. And now we look at the Excel design sheet. Now in the Excel design file of the bar screen, design of the bar screen, first we have to input the depth to width ratio, which is taken as 2 in the case of rectangular channel. The slope of the channel is taken as 0.002. The peak discharge is taken as 0.694 meter cube per second, and the Manning's coefficient is taken at 0.012 for concrete. Now by using the Manning's formula, we calculate the width of the channel to be 0.52 meters. The depth of channel is calculated as 1.03 meters. The approach velocity is calculated as 1.30 meter per second. We have to input the bar size, which is 8 millimeters, input the bar clear spacing, which is 50 millimeters, and the number of bars is calculated as 8.76. We have round it up to a greater number, which is 9, and the actual spacing came out to be 48.47 millimeters. We have to input the angle of inclination with horizontal theta, which is 75 degree. The freeboard is input as 0.3 meters, and the total depth came out to be 1.33 meters. The length of one bar is calculated as 1.38 meters, and the projected length is 0.357 meters, and the flow velocity in screen is calculated as 1.733 meter per second. Now we calculate the head loss by using the first Christmas formula. The beta is taken as 2.42 for rectangular channel. The W is max cross-sectional width of the bars facing the direction of the flow. The B is the minimum clear spacing of the bar. The HB is the velocity head of flow approaching the rack. The angle of inclination was 75 degree and the head loss is calculated as 0.109 centimeters. Again, by using the orifice formula, we calculate the head loss in a clean condition. In the clean condition, the head loss came out to be 9.55 centimeters. So we have to take the greater of the two values to provide a vertical drop so as to maintain the level of the water in the clean condition, which is 9.55 centimeters. And in third, we have to calculate the head loss in the 50% clog condition. The velocity in half clog condition in the screen will be twice of that in the initial clean condition. The head loss is calculated as 75.25 centimeters, and in the check it is shown as not okay. Increase the freeboard because the freeboard is not sufficient and we have to increase the freeboard. So now putting the freeboard as 0.8 meters, it came out to be okay. The check came out to be okay. So when the height rises to above level, manual or automatic cleaning should be done. And in the design summary, we have the inclination, the total width of the chamber, width of the flat plate, new clear spacing, the length of one bar, the number of bars, the projected length of bar in plan, the vertical drop after bar rack, and the rack cleaning height level when depth rise. The drawing of bar screen with chamber is auto-generated in the Excel file. Everything is auto-generated and everything is linked. The number of bar was 9, 8 mm width bar, 48.47 clear spacing. The depth of water in the clean rack was 1.032 meters. The velocity of approach is 1.302 meter per second. The total width of the channel is 0.52 meters. The height drop after the bar screen is 9.55 centimeters, and in the 50% clogging condition, the depth will rise up to 75.25 centimeters, and up to the freeboard, the depth is 1.832 centimeters. So we just have to input where there is yellow color, and all the designs are calculated automatically and the drawing is generated automatic. So I will be putting this Excel file in the description of this video. Also, if there are any suggestions and modification needed, please leave a comment, and thanks for watching.